All right. So for problem number 8, it states use a right triangle to write the following as an algebraic expression. So we have sine of cos inverse of 5x, and we're going to assume that x is positive and that the functions are defined for the given expressions. So we won't worry too much about the domain issues. We just want to take care of the algebraic stuff. All right. So first of all, if I want to evaluate this this trigonometric expression, first thing that I got to do is just take care of the inner function. The inner function is defined as cos inverse of 5x. So what I'm going to do is rewrite cos inverse of 5x by first setting it equal to theta and rewrite this as in terms of cosine. Right? Remember, if you have cos inverse of 5x equals theta, then when I swap the ordering, meaning if I swap theta and the 5x, then we'll have cosine of theta equals to 5x. Okay? Cosine of theta is equal to 5x. Now recall, cosine of theta from right triangle trigonometry is always equal to the adjacent over the hypotenuse. Right? If you ever forget that, there's always that acronym SOHCAHTOA. So for cosine, we have adjacent is over hypotenuse. So what we're going to do is we need to create a right triangle based on what I have here. In particular, since we have adjacent over hypotenuse is equal to 5x, right? Because remember, cosine of theta by definition is adjacent over hypotenuse, which is also equal to 5x in this problem. Based on your right triangle, you can label at least two of the sides, right? Your adjacent is going to be 5x, but what do you think your hypotenuse is going to be? Anybody have any ideas what the hypotenuse may be? Think about it. You have a ratio, adjacent over hypotenuse, right? Adjacent divided by hypotenuse. If we have that ratio is equal to 5x, then 5x divided by what number will still give me back the 5x? Or yeah, 5x divided by what number gives me 5x? Yeah, 1. So we have that the adjacent is going to be 5x and the hypotenuse is going to be 1. All right, so here is my right triangle now being drawn. That's the right angle. Here is theta. If we label the three sides corresponding to theta, we have opposite, the adjacent down here, and the hypotenuse. I know the hypotenuse is 1. The adjacent is 5x. What side of the right triangle is missing? The opposite. So what you're going to do is find the value of the opposites, the length or the measurement of the opposite side of the right triangle. Now, what can I use to help me figure out the opposite side? If I know two sides of the right triangle, what can I use? What formula? No, I don't know what that means. I don't know what 1 squared plus 5 squared equals r squared means. What is the general formula for right triangles if you know two of the sides?
Isn't it a square plus b?
That's right. You have this formula called a squared plus b squared equals c squared. Do you now know the name of this formula?
I know it's not law of science.
No, it's not law of sines. It's called the Pythagorean theorem. All right, it's the Pythagorean theorem, a squared plus b squared equals c squared. It means that the two non-hypotenuse sides, like for example, the opposite squared plus the adjacent squared is equal to the hypotenuse squared. The opposite, we know, we don't know. That's what we're trying to find in this problem. The adjacent I know is 5x. So I have 5x, where all of that is being raised to the second power, and then 1 squared. So essentially what you have to do here was make a right triangle. You'll see that there's one side missing. That side that you're missing, you find it by using the Pythagorean theorem. Now, to evaluate the Pythagorean theorem, we need to do 5x squared and 1 squared. So 5x squared is going to be 25x raised to the second power. You have to square both the 5 and the x. 1 squared is 1. So you have opposite squared should equal to 1 minus 25x squared, because I'm allowed to subtract 25x squared on both sides. On the left, it would cancel. And to get the opposite by itself, you just simply take the square root. So we say the opposite is going to be the expression 1 minus 25x squared. All right. Now that I have the 3 sides of the right triangle, I'm ready to solve this problem. Right? Originally, this problem asks us to find sine of cos inverse of 5x. The very first step in for me to solve this problem was to take the cos inverse of 5x and set it equal to theta. Right? If you guys remember, we set this equal to theta. Oops, that didn't look like theta. No, it does. So we can rewrite this as just saying that, okay, sine of cos inverse of 5x is just simply sine of theta. And if you want sine of theta now, give it 1 second to load up on the screen. If you want sine of theta, all you got to do is just use the right triangle, because the three sides are all labeled with respect to your angle theta. So from SOHCAHTOA, you should know that sine of any angle of your acute angle here should be opposite over hypotenuse. So your opposite is square root of 1 minus 25x squared divided by 1, which is equal to the square root of 1 minus 25x squared. And that would be the solution to problem number 8 on the sample final.